Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Faizah Faiqah Binti Abdul Salam with matric number B20EC3003, and this is a presentation for project Sarjana Muda 1, and I'm doing application development, which is prawn farming monitoring system. First of all, I would like to express my gratitude to the panels that are watching this, and also my supervisor that helps me throughout my progress. First of all, let's see an overview of this presentation. We start with introduction that has problem background, aim, objective, and scope. The second would be literature review, which shows current system analysis and the technology used for this system. Then we move on to methodology. For this system, we're doing agile, and we'll show software and hardware requirements. And next, there's requirement analysis and design, which shows use case, system architecture, and interface design. And finally, the conclusion. Growing prawns can be a complex and challenging endeavor. So raising them requires a considerable amount of knowledge, effort, and resources, from managing water quality and temperature to ensuring adequate nutrition and disease control. There are many factors to consider when growing prawns. So for Sarfas Enterprise, the problem background that they face is that they have failed harvest due to low quality water. The second one is they still using manual inventory bookkeeping, and finally their business expansion possibility. So this project aims to develop a mobile application for prawn farm monitoring system, and this system should consist of these features, which is supervised water quality through its pH value, inventory module for recording their inventory, and dynamic setting for additional ponds. The objectives of this project is first of all to elicit requirements for stakeholders and realize it into a system. Secondly, to design and implement the best architecture and good user interface that satisfy the requirements. Next, to test the system to ensure the workability of the system, and finally to deploy and maintain the system to benefit the users. The scope for this project is due to the time constraint, the system will only consist of 3 main modules, which is pH reading module, inventory, and pond. Due to limited budget, the system will only provide one pH sensor only, which covers only one pond. So this system will only consider pH value of the pond water, which is to test whether the water's acidity is healthy for prawns growth. Next, the system must use common Bahasa Malaysia words as the primary language in the system, and should be able to manage all 3 ponds that exist currently and consider possible expansion in their business. Next, this system architecture should be ready for future expansion. So it is possible that the system to add more IoT-based monitoring. And finally, this system will have to be in mobile application form. This aims to reduce complexity for the stakeholder to learn new technology, considering they are not really tech savvy. In addition, it is important that the interface implements good design following the Schneiderman 8 golden rules. So there are few existing systems that had done what I'm trying to do for this project. The first of all is My Fish Manager apps. Okay. The second is Innovasi. Third one is a research study titled Automated IoT-based Smart Aquaculture Shrimp Farming in Brunei from Daud Pashmutu and 2022. And finally, Freshwater Shrimp Farm Monitoring System for Bangladesh based on Internet of Things, Udin et al. 2020. We will analyze 5 things for every system. The first of all is water quality variables that is covered in the system. Second is the inventory management. Third one is pond management. Fourth is language constraint, and finally the platform used to run the system. So in My Fish Manager, okay, they do not cover water quality monitoring at all. So they are focused in inventory and pond management. The language used is English, and it is in mobile application form. Next one is Inovasi. For Inovasi, they cover dissolved oxygen, water temperature, salinity, chlorophyll, blue-green algae, turbidity, and colored dissolved organic matter to monitor the water quality. But they do not have inventory nor pond management. They use English language in their system, and it is in mobile application form. Next, based on the research paper by Daud Pashmutu and Wan, the water quality variables covered by them is pH value, water temperature, and turbidity. They do not cover inventory and pond management. They use English language in the system, and the platform is web application with integration of WhatsApp API. Finally, in Udin et al. Paper, they cover pH value, dissolved oxygen, salinity, temperature, and turbidity, but they do not cover inventory and pond management. They use English language, and they use web application platform with integration with SMS. From the analysis, we can see that none of these systems had covered water quality monitoring system as well as inventory and pond management, and none of them use Malay language since it's not based in Malaysia. For this project, I plan to cover water quality, inventory, and pond. Since for now we're just considering the pH value of the water, but for future expansion, it is possible to add other variables to monitor the water quality. So for this system, we are using Flutter. For the database, we are using Firebase, and for the hardware integration, we're using Arduino. For this project, we're doing agile methodology. Sprint 0 consists of concept phase and inception phase. So concept phase was done when proposal form was submitted. It was also have been verified by the panels. In the proposal form, the problem background was identified and a solution was proposed. And during this phase, the objective, scope, and system requirements also was identified. And next, in inception phase, there's an interview conducted with the owner of Prawn farm. The question asked were generally regarding on the business flow. Besides, the sites were observed to see the activities conducted by the stakeholders. And from the observation, there are some issues identified that should be resolved using this system. Then after the interview and the site visit, I have prepared the system requirement specification and the system design documentation along with this report. Next, for Sprint 1 onwards, it will be conducted in PSM2. Okay, the activities in the sprint inception phase. Okay, so in this phase, we'll set up the environment for this system. And first and foremost, all the technologies used to develop this project, such as VS Code, Flutter, and Firebase, must be installed. Next, the device slaves to run the code must consist of Android device or emulator. And finally, the project folder must be set up and pushed to GitHub for version control. In Sprint 2, there will be construction phase and release or testing phase. In construction phase, we'll start the code implementation for use case login and pawn module. It covers 5 use cases: view all pawns, read pawns detail, add pawn, delete pawn, and edit pawn. So the activities for each use case consist of front-end and back-end implementation. In release or testing phase, the stakeholders will test the features and all the comments and feedbacks will be taken for further improvements. And the test cases for the use case can be found in the SED. Next, in Sprint 3, there's also construction and release or testing phase. Okay, but in this sprint, the construction phase consists of inventory module. It covers use cases which are read expenses report, add expenses, delete expenses, edit expenses, read harvest report, add harvest information, and delete harvest information, and edit harvest information. The activities for each use case consist of front-end and back-end implementation as well. Next, for Sprint 4, consists of construction phase and release or testing phase as well. But in construction phase, we'll make the code implementation for PH monitoring module. The activities for the use case consist of the hardware installation with its embedded code, and front-end and back-end implementation. Finally, in Sprint 4, will be the production phase. In this production phase, we'll deploy the system. This production phase goal is to keep the system running and facilitate the users. Users are expected to implement the system in their business process. So if any issues raised, it should be attended and resolved to ensure longevity of the system. Next, let's discuss about the software requirement of this system. We'll be using Arduino IDE 2 for the IoT programming language. We'll use Flutter SDK for the framework of mobile programming. Next, we'll use Visual Studio Code as the editor, Firebase as the database management system, and finally, Android operating system. Next, hardware requirement for this project will consist of ESP32 Wi-Fi module for the Arduino board, pH sensor kit to read water's pH value, DC supply 9 volt for the battery supply for Arduino board, connecting wires to connect between the components. The breadboard acts as a base for all components. Mobile device with internet connection for testing purposes, USB connector for testing purpose, and finally a computer or laptop with internet connection for software development purpose. Next, this is the general use case diagram for this system. Okay, as you can see, there's 2 actors, owner and staff. So they are login, monitor pH value, manage inventory, and manage pawns. So in monitor pH value, we will read the pH value report for both owner and staff. Next, in manage inventory, only owner is allowed to access this module. Okay, in this inventory module, there's read expenses report, add expenses, delete expenses, edit expenses, read harvest report, add harvest information, delete harvest information, and edit harvest information. Finally, in pawn module, okay, also only owner is allowed to access this module. So in this module, owner can view all pawns, read pawns details, add pawn, delete pawn, and edit pawns details. So this system uses MVC architecture, and as you can see on the screen, I divided into the subsystems. So in pH monitoring, okay, there's pH report pH as the view, and the controller is pH reading controller, and the model is pH reading. Next, for the inventory, there are 6 view pages: add expenses, add harvest, edit expense, edit harvest, expenses, and harvest page. Next, it will use 2 controllers, which is expenses controller and harvest controller. There are 2 models, which is expenses and harvest. Next, for pawn module, there are add pawn page, edit pawn page, pawn detail page, and pawn page for the view. For the controller, there will be pawn controller, and model is pawn. These are the example of interface design for this system. So this first picture here is a dashboard for the owner. In this dashboard, the owner should see the summarized pH reading and harvest information for each pawn. Okay, and there's also a bottom nav bar, so he can easily access home, pH reading, harvest page, finance page, and pawn page. Next, for the second picture, this is an example of pH reading page. Okay, this is personal request by the user itself. Okay, they want to see the information in a calendar form for them to easily track like their progress for their pawn. So first of all, they have to choose the pawn that they want to read, and the calendar will display the pH reading for that day. In conclusion, though Safa's enterprise has done their best to sustain their business, they still need help to organize their business and help them monitor the main factor of the prawn's health, which is the water quality. So far, the existing systems in the market cannot satisfy what Safa's enterprise need to ease their business flow. So besides not having all the features in one place, it is also hard for them to learn the system considering the constraints. So this system, prawn farm monitoring system, is proposed so it can hopefully give the stakeholders some peace of mind and ease their business flow by being the perfect tool for them. That is all from me. Thank you so much for listening, and hope you have a nice day ahead.